There we go. That's better. Now it's really big. Okay, so this is what happens when you think to yourself, aha, I should do video streaming. And then you think, but video streaming is stupid. And so you build this. Because basically every live streaming tool in the world spends a lot of effort trying to create a situation that is very hard to create, which I never want, which is the situation where everybody watching the stream is seeing approximately the same thing at the same time. That's why they call it live streaming. You're seeing what's actually happening at the event right now. Everyone is seeing what's actually happening right now at the event. That's terrible. I actually never wanted that, because what happens if you come in 5 minutes late? You miss the beginning of the event. That's terrible. Then now we're back to the whole live television problem that we had, back before I was born, where you had to actually go to the TV when the show was on to watch it. No one ever wanted that. That was just a limitation of technology. And so we spend all of this effort in the live streaming world on the internet doing something that on the internet is really hard just to recreate an experience that was shitty in the first place. So this is better. Maybe. I mean, I don't know that. It's probably worse. This is 12 lines of code. I mean, it looks like more because there's imports. But if you start here, where the code starts, this is exactly 12 lines, including the blank line. And it implements all of the easy parts of live streaming, which I posit are the only parts you want. So here we go. So it would be a few more lines if I was being intelligent at all. Like right now I just take the port number and the path to the file and the MIME type of the file as 3 arguments, and if you pass a different number of arguments, it just crashes. Because fuck you. So, fun things like that. So I'm just like, yeah, so we'll run on that port, and then run the app with that path, and I do some encoding on the MIME type for reasons to make it easier. So yeah, this is my whole app part. This part, all it does is say run that app on this port, basically. The app takes in the path to a file, so this serves exactly one file, because why did you want more than one stream? If you want more than one stream, run the server more than once onto multiple ports, obviously. Way easier. I wrote this in like an hour, okay? And then it takes in the MIME type, because probably we should tell the browser what MIME type, otherwise it'll try and download our infinitely long file, and that sounds bad. And then it's an application, why not? Because it is one of those. Okay, so I say with binary file, reading only from the path. So there we go. I've opened up my file, which we hope is probably a video file. I mean, it could be a text file, because if I demo it, it'll definitely be demoed with a text file, because that's easier to see. But it could be any file, but probably a video file, since I'm claiming this is for streaming video. But it could be anything. It could be audio. It could be a text file. You're totally streaming text, live streaming text. Such a good, everyone wants that, live streaming the text. Yeah, so here's my file handle. I set the buffering on the file to block in my chunk size, so that my OS buffers and my chunk size going down over the HTTP stream will be the same size, just for convenience. There's not any good reason to do that, necessarily. It just means that when my reading blocks, it'll actually be because it needed to block in order to get enough for my stream, instead of blocking at random other times. Basically, that's why I did that. And then I'm like, okay, so we should respond with a stream. We should say we are successful and set our content type to the one that was passed in the command line. And the way that the web application interface's stream responder works is I just get this write function and this flush function that it passes into me. And I say, okay, forever, get chunk from the file, and get some means that if there isn't enough, just get me whatever there is. And so I take up to 4K chunks out of the file, and I write them using write, which is this thing I got passed. So that's from the internals of the web server that I may or may not be using. It'll pass me a write function. I just call it. Then I flush, because I'm streaming. So probably I should actually send you the bytes when I'm done writing them, instead of just being like, more buffers can happen. We should flush pretty constantly so that you're actually getting stuff down the pipe. And then if the file system is reporting that I'm at end of file, normally what your web server would do is stop. But instead what I do is wait, and then go again. And if I'm not at the end of file, then I don't wait, I just go again. So basically I just read 4K chunks out of the file, until I hit the end of the file, and then I just wait 2 seconds, and then I check and see if there's more things in the file. And then if there is, I get more 4K chunks, and if there isn't, then I wait again. And that's the whole server, because that's all you need. So,
Your delays in nanoseconds? Your delays in nanoseconds?
Yeah, my delays in nanoseconds. Whew.
Cool.
But I wanted 2 seconds, so I just write a lot of zeros.
Yeah, I was reading that, and then you said 2 seconds. I'm going, that's gotta be nanos, because
it is. Or no, I think it's microsecond. Anyway, it's ridiculously small. Well, it's just because the delay isn't being handed off to the OS. It's being handed off to the Haskell runtime, so I can do a lot more granularity. Anyway, yeah. So this is basically it. So the only thing that this is missing, hypothetically, one might want, is if you were going to allow seeking outside of the bounds of what has currently been buffered by the browser. So what this will do is the browser will start buffering, and if you seek inside the buffer, it'll be fine. And if you play, it'll be fine. And if you seek all the way up to the end of your buffer, after it's fully buffered, then you'll get this experience of basically a live stream. It's not a guaranteed live stream because I'm not doing any timing checks because you didn't actually want that, but it'll be pretty close. But if you click outside your buffer, it'll probably not work, and that's because what most browsers do when you click outside the buffer is they send a range request to the server to say, okay, give me the bytes starting at this part of the file. But I didn't implement those headers because this took me an hour, and I'm done. And this will work for almost everything you wanted, and a whole lot of things that you normally don't get. Like if you want to watch from the beginning and you're 5 minutes late, you just go to the URL and it'll just start playing at the beginning. You don't have to worry about it. And when the event is over, instead of the page being replaced by a page that's like, this stream is now gone, it just still works. You just watch the whole event from the beginning because it's just a file. And then you can actually take this away later, just kill the process and have your normal web server serve the file now that the file is done. If you wanted to do that. Or you could keep it running, which is kind of useless, but you could. And that would work too. Yeah. So that's what I did.
Do they save bandwidth by doing all the stuff you say they do? Making you watch what's available at that time?
So if you were going to build television network style broadcast, rebroadcasts, data centers and network operation centers all over the country and, going out over dedicated cables and such, you could definitely save a lot of bandwidth by forcing people to log into a specific point, right? Like an actual television network, when they force you to start watching here, it means that they can just restream to you exactly the bytes they're sending to everyone else in your neighborhood who's watching that channel. It's great. But on the web, we don't use any of that. The internet protocols support doing all of those kinds of things, and no one does them, especially not on the web. It just can't be done from the web's perspective. So everyone's always downloading all of the bytes all the time anyway. So the only thing they would be saving is maybe if you ban seeking, then you can save people continuously go. No, that doesn't help anyway. I don't think so. Not really.
They could potentially set up their player to automatically seek to a particular point that was told to it when it first started up. But
yeah, I guess they would.
Right.
What they would, the amount of bandwidth they would save would be people who come in late, since they can only start from now, would not download the beginning of the event. So if you count on people coming late, you would save the earlier part of the event's bandwidth. That would be it, though. If everyone actually came in when it started, it would be the same as this. Yeah. So yeah, real-time streaming definitely has advantages in a lot of mediums. I mean, there's a reason. Cable TV doesn't do it just because they're jerks. They do it because they're jerks, obviously, but they
do it now because they're jerks.
Well,
they
but
weren't used to be jerks.
Even now, there are technological advantages to the way they're doing it from their perspective. They're just not significant enough for us to consider them real. But there are potential advantages, because they do have millions of people all watching exactly the same stream. They can cache the stream on as many endpoints as they want and rebroadcast, and it's all totally kosher, right? So there are advantages there. But when you're in, basically the reason we don't believe that that's necessary is because YouTube exists. And all YouTube does all day long is stream millions and millions of completely different videos starting at completely different points to completely different people, and they stream the whole file every time. There's no magic, because there can't be, because you just go to an arbitrary video and hit play, and it works. And so, so on the web, basically you're always downloading the whole thing all the time, which is not necessarily a good situation, but is what tends to happen, so this ends up being the same as that. The biggest advantage here is that you don't need any special player to play this. You just use any web browser. You just point it at the URL, it'll start downloading the video chunks, the web browser will start playing the video, just like with the normal buffering the video, playing the video, same as it would if the video was all there. The browser doesn't even know the video isn't all there, it has no way of knowing. All it knows is that when it gets to the part where the video is not there yet, your download got really slow. It doesn't know why your download is so slow, but it is. It's just not getting very many bytes. So the potential problem here is that, this is not a real problem, but hypothetically, the browser could time out. If it took too long between chunks, then it could just time out and say, man, I'm not getting the rest of this file. But as long as it's still getting dripped chunks, that's very unlikely to happen. And because your video is being produced at kilobytes and kilobytes a second, you're probably going to be streaming chunks pretty constantly, so that's not really a major concern. But hypothetically is a thing that I don't deal with specifically here. I just mostly count on the fact that video gets produced fast enough that that won't happen. This also doesn't handle like the streaming itself, right? Like the creation of the stream. This just assumes there's a file on disk. But usually your recording software has a way to make a file appear on disk. And getting files that are on one disk to suddenly be on another disk is definitely a solved problem, so I didn't solve that one either. I'm going to use NFS over SSH, and then FFmpeg from my webcam onto my NFS mount, obviously. But like, you could do something else.
I'm guessing this is Haskell, yeah?
Yeah, this is definitely Haskell. Yeah, why would I show anything else?
So what? How do you know what is keyword and what's yours? For example, just before, after the dollar is a keyword?
No, there are no keywords. Do, sorry. Do is a keyword technically.
Oh, everything in yellow is keyword, yeah?
Well, everything in yellow that isn't do is not a word. So, and no, actually. So the only things in here that are what you might call, so this line is a type signature, so there's like this is syntax, these colons are technically syntax, these arrows are technically syntax, like I can't redefine these to be something else. The equals sign is syntax, this backslash is syntax, because that introduces a lambda. This arrow is again a syntax, and do is technically syntax, although it's a little more different. Everything else is not syntax. This is just a function named $. This is just a function named equals left left. This is just a function named dot. This is a function named flush. Like there's no difference. It's all just functions named things. This is the square brackets and parens are technically syntax. The list and tuple syntax is syntax, not just a function. Although it's sugar. I can write them such that they're just a function, which is fun. I'm going to do that right now for no reason at all. So it would be this. There. Now there's no syntax there. That's just functions again. This is just a function named colon. This is just a function named open paren, comma, close paren, obviously. This is just a function that takes no arguments named open staple, close staple that returns an empty list. What? It's totally legit. I would not write it that way, but
Clearer now, isn't it?
yeah. I didn't say it was clearer. I said if I wanted to get rid of the syntax is optional. Yeah.
My question was wrong. You have a lot of imports, so you import types, yeah? So which are your,
So all of my imports are qualified except this one, because I'm a jerk. This one I only implement, that's there. Now everything is qualified. So I can tell where everything came from. But these are all functions that I'm importing. So I import a function named forever and when and getargs and with binary file and h_is_eof, and these are types and type constructors that I'm importing, and then my delay, and then these, instead of saying which things I'm importing, I'm giving a prefix name. So anything that starts with BS is a byte string, like here. So all of these imports are set up so that I can tell exactly, and I almost always do this, except for like imports that are like painfully common so that people will definitely know where that came from. like this top one, everyone knows. Like everyone who's coded in Haskell for very, very long knows where forever comes from. So I didn't have to put that there. I could just import control monad, say forever, and people would know. So I sometimes leave that one off, but anything else, I try to make it painfully obvious where things come from, because otherwise you're going to be like, where does this word come from? I don't know, but now I can just go like this. Oh, it comes from there, I found it. And then I can look at the docs super fast. So that's basically...
So actually, the only variables that you declared are chunk size and delay and app.
Chunk size, delay, app, and main are the only things I declare in here. Yep. Yeah.
So what that means? Path is the path to the file, yeah?
Yeah, path is the path of the file, which gets passed in as a command line argument. So here I grab all the command line arguments, which will give me a list of all of the arguments as strings. And then I just pattern match against a list of 3 arguments. So if you give me a list of a different number of arguments, it'll scream at you. So, for example, if I give it nothing, it's like error. I give it 1, error, 2, error, 4, error, but 3, it's like, okay, but now it's complaining because this is not a number, and it's expecting a number because it's trying to run on a port. There, now it's running. It's serving a file named 2 with MIME type 3 on port 3000. It totally works. I can show it working. This is, here. So on 3000, I'll serve high as text plain. Right, and then we'll so there, that's everything currently in that file. Come on. I can type.
So switch your keyboard back to QWERTY?
Oh, my fingers are not on the keyboard. That's the problem. Okay. So this is me streaming the high text file, and this is me using curl. So you can see curl's just sitting there waiting for data. So this is where a timeout could happen, right? If you were doing this manually. But obviously in a real video stream, new bytes are coming in all the time, so you're not going to time out. Anyway. All right. So I'm like echo hello. I put it in high, and there it is. It shows up. Do it again, and then again. And it keeps showing up. Look, I'm live streaming a text file, you guys. Yeah, that's it. Any other questions?